unlocking the full potential of the circular economy for carbon neutrality. Global resource extraction and waste generation have reached unsustainable levels, fueling environmental damage and climate change if no action is taken. As populations and economies expand, the limits of our linear take-make-waste model are being tested like never before. We must transition to more resumption and alleviate greenhouse gas emissions. The circular economy offers a holistic solution by designing out waste and optimizing material and energy reuse. As the biologist Paul Hawkins said, the circular economy isn't a nice-to-have - it's a got-to-have. Discover how leveraging industrial synergies contributed meaningfully to locally driven climate action goals in our feature article, Leveraging Industrial Symbiosis to Slash Carbon Emissions, Case Study Evidence on Accelerating Carbon Neutrality Through Regional Cooperation. Leveraging Industrial Symbiosis to Slash Carbon Emissions, Case Study Evidence on Accelerating Carbon Neutrality Through Regional Cooperation. As millions across the globe strive to accelerate progress towards internationally agreed sustainability goals like the Paris Agreement and UN Sustainable Development Goals, Global Empowerment Leadership is proud to present our 2024 newsletter series. Last year, we explored pressing sustainability challenges including green growth, climate action, and empowerment through education. This year, we shift our focus to circular economy strategies, an area of innovative, cross-sector solutions that hold great promise for the transition to global sustainability. The circular economy represents a systemic shift away from the typical take-make-waste linear model and towards an industrial system that is restorative and regenerative by design. By optimizing resource use through techniques like reuse, repair, refurbishment, remanufacturing and recycling, the circular economy aims to decouple economic activity from finite resource consumption and wasted output generation. Opportunities across industries and communities to design out waste and promote environmental stewardship. To help advance understanding of circular economy strategies and their potential, our 2024 newsletters will explore major themes like urban industrial symbiosis, sustainable minerals and materials management, and circular business model innovation. We are excited to present cutting-edge case studies and research helping industry, government and civil society alike along the journey towards a truly regenerative and inclusive economy. We hope these newsletters prompt new insights and foster on social media using #CircularEconomyLeadership. Now, let's explore our first circular horizon: the role of industrial symbiosis in reducing carbon emissions and supporting carbon neutrality goals. Introduction. Achieving carbon neutrality is a pressing global imperative to mitigate the worst impacts of climate change. Governments and industries worldwide are exploring an array of strategies across sectors to decarbonize economic activities. Industrial symbiosis, the exchange of waste and byproducts between facilities, shows promise as an approach to boost resource efficiency and reduce carbon emissions. As a system optimization of industry that mimics resource cycling in nature, industrial symbiosis holds opportunities to design waste out of production processes through reuse and recycling. This inaugural newsletter of our 2024 Circular Economy series explores the carbon mitigation potential of industrial symbiosis. Our first article examines a case study of waste exchanges instituted between coal, aluminum, electricity and steel facilities in a major Chinese industrial city. Through analyzing material and energy flows before and after establishing these symbiotic linkages, the study quantifies resulting reductions in the city's carbon footprint. The findings provide empirical insight into how optimizing industrial systems through industrial symbiosis can support low-carbon development strategies. Leveraging industrial symbiosis for carbon neutrality. A central question on the path to carbon neutrality is how to maximize emissions reductions across industrial sectors. Urban industrial symbiosis shows potential as an effective solution by optimizing material and energy flows through closed-loop exchange. Huan and Han, 2022, provide empirical evidence on the carbon mitigation potential of industrial symbiosis using a case study in Guiyang achieved through 8 synergies established between the city's coal, aluminum, electricity and steel industries. The design synergies included substituting steel slag for clinker production, replacing cement raw materials with phosphorus slag, utilizing aluminum waste in concrete, recycling coal gang and fly ash, waste heat recovery, and steel scrap recycling. Through these exchanges, an estimated 1.09 million tons of CO2 emissions per year were avoided compared to business as usual in 2012. This 1.09 mount reduction represented over 3% of Guiyang's total annual carbon footprint. The results validate industrial symbiosis as an impactful pathway for supporting carbon neutrality aims. By optimizing material and energy flows across integrated industrial and urban systems, substantial emissions mitigation can be cost-effectively achieved. The study provides empirical foundation for the low-carbon benefits of industrial symbiosis through detailed investigation of a representative industrial case. Advancing carbon neutrality through industrial symbiosis. As the scientific urgency of climate change mounts, achieving carbon neutrality has become a pivotal global imperative. A diverse suite of technical and socio-economic strategies will be required across all sectors to decarbonize and realize this pressing target. As discussed in the introduction, industrial symbiosis shows promise as an effective pathway supporting carbon-neutral efforts. The case study presented in this paper provides empirical evidence that industrial symbiosis can meaningfully reduce urban carbon footprints. By optimizing material and resource flows through 8 tons of annual CO2 emissions were avoided, representing more than 3% of the city's total carbon footprint in the business as usual scenario. These findings imply that industrial symbiosis can play an important role in helping accelerate the transition towards carbon neutrality. By improving closed-loop flows of inputs, outputs, wastes and byproducts through integrated industrial and urban systems, industrial symbiosis appears able to drive meaningful carbon mitigation. As a systematic innovation approach, industrial symbiosis shows potential as a practical lever that regions and industries can pull to decarbonize within current technical and economic boundaries. Of course, barriers to adoption still remain that demand ongoing attention. But as a proven solution, urban industrial symbiosis warrants further support and scale up as part of broader carbon-neutral strategies being pursued around the world. Methodological considerations. To quantify the environmental benefits of the urban industrial symbiosis case study, this paper employs a hybrid methodology integrating a process-based inventory analysis with input-output analysis, IOA. Policy and practice implications. The results of this case study have important implications for accelerating carbon neutrality strategies through industrial symbiosis. Several policy recommendations stem from the analytical evidence highlights industrial symbiosis as an effective pathway supporting carbon mitigation targets. Policymakers should consider industrial symbiosis as a valuable lever within carbon-neutral roadmaps. Technical guidance underscores the need for industry-focused decarbonization strategies. Industrial symbiosis provides a tack to stimulate relevant synergies. Third, transboundary material and waste management is key to optimize regional metabolism. Multi-jurisdictional coordination mechanisms could advance cross-boundary exchanges like the analyzed case. Overall, the research highlights industrial symbiosis merit for resilience through material preservation. It affirms the approach warrants continued policy prioritization to maximize carbon mitigation contributions from industry transitions. Conclusion. This study has demonstrated the substantial potential of industrial symbiosis to contribute to carbon neutrality goals through industrial symbiosis deserves recognition as a tactical enabler well positioned to aid the difficult mission of decarbonizing high-impact industries. Adoption of this systematic innovation approach merits broader consideration in carbon mitigation strategies worldwide. Only through determined multi-level action can humanity overcome the climate emergency and build a truly sustainable future. #Industrial symbiosis, #circular economy, #carbon neutrality, #sustainable development, #low carbon.